Hi, welcome back to Imperium Learning. This is the second video in a two-part series that concerns the application of the Perron unit root breakpoint test. I'm just going to show you now very quickly how to apply the test, and I'm actually going to show you two variables which I think are very instructive to help you understand why we apply a breakpoint unit root test as opposed to just a standard unit root test. I'm going to click on Learn AHP, and very quickly I'm just going to graph it just so you can remember what it looks like. And in order to apply it, I'm going to click on View, the Perron break unit root test, and then I'm going to click this option here, the breakpoint unit root test, like so. Now, as you can see from the this window here, there's a lot of stuff to kind of specify. So the first thing I'm going to do is I'm going to specify both the trend and an intercept, and I'm going to say that both the trend as well as the intercept have broken around here. And for the breakpoint selection, I'm going to click on User Specified, and the reason that I'm going to do this is because using the Chow test, I've already identified the structural break date. Now in this particular case for Learn AHP, it's September of 2007, and the lag length is selected by the F statistic. And so all I have to do then is click on OK, and look right here. These two values here are the most important for interpreting the results of your unit root test. The T statistic is -3.3659, and the p-value is above 0.1. If it's above 0.1, what does that mean? It means we cannot reject the null hypothesis. What's the null hypothesis again? It's that a unit root is present. So we can't reject it, which means it's quite likely that a unit root is present, and that means that Learn AHP without being differenced is a non-stationary variable. But here's the thing, we also want to make sure that D Learn AHP, the first difference of Learn AHP, is integrated to an order of 0, which means that it's stationary. We want to make sure of that. So what are we going to do? We're going to click on View, we're going to click on Breakpoint Unit Root Test, and then we're going to select the first difference. And so then what we're going to do is we're just going to leave the trend specification as it is, and then what we are going to do is type in the structural break date again, which is the September of 2007. And finally we click on the F statistic like that, and then we're going to click OK. And as you can see there, the T statistic is -3.89, which is more negative than at the 5% level, and that means that we can reject the null hypothesis. And so that means that the first difference of Learn AHP is stationary. So we know that Learn AHP is integrated to an order of 1. Now I want to just close this for a second, and I would like to show you a second variable, which is my Learn GDP. Now this is actually a trend stationary process. As you can see, the line is trending upwards, but the variance of the line is pretty much constant. You can see that it's just trending upwards like that. So it looks as if the data generation process is an actual function of time. And so because of that, what we're going to do is we're going to do let me just check again. I think our chosen breakpoint date is March 2008. Yeah, let's choose March 2008. So we're going to do a breakpoint unit root test. I'm going to specify both a trend and an intercept. It doesn't appear to me as if the trend has broken. It seems to be pretty much the same as before, but the intercept is obviously broken. So as a result, I'm going to leave that there. User specified, again, we use the chow test for this particular variable, so we can write in March of 2008 like so. And we'll apply the F statistic like that. And we'll click OK. Now look at this. Look at the results there. It's less than 0.025, which is obviously less than 0.05. And so as a result, we can actually reject the null hypothesis that Lun GDP has a unit root. So in other words, this is an example of a trend stationary process, because we can reject the null that it's a non-stationary variable. That will actually have a lot of implications, particularly when we go to estimate a vector error correction model, which I'll be doing later on in this series. We're still going to have to include this in our model, but we'll be including it as an exogenous variable, and in fact we're going to be using a residual series rather than the variable itself to do so. And so one thing I just wanted to show you very quickly was the difference between the breakpoint unit root test and say an ordinary unit root test, like say the augmented Dickey-Fuller test. So bear in mind, p-value right there is less than 0.025. That means we can reject the null that there's a unit root. Let's just do the augmented Dickey-Fuller test, and let's specify a trend and intercept. Let's just leave the lag length like that. Or actually, can we do the f-test? No, I don't think we can. We can only use an information criteria. So we're just going to leave it like that, and we're going to click OK. Look at that. The p-value is 0.8347. Look at the null. Lun GDP has a unit root. So in this particular instance, we would be concluding that Lun GDP is a non-stationary variable. So this backs up the point which was made in my very first slide, which was that failure to conduct a unit root test which allows for structural breaks creates the risk of falsely accepting the null hypothesis that a unit root exists. So that right there is a clear example. Because the augmented Dickey-Fuller unit root test doesn't allow for structural breaks, the p-value produced is 0.8347. That means we cannot reject the null that Lun GDP has a unit root, and therefore if we were using that test, we would falsely conclude that this is a non-stationary variable, when in actual fact it's a trend stationary variable. So I hope that this video has proved useful. If you think it's a good quality video, please don't hesitate to thumbs up and subscribe. And yeah, I think I'll wrap up the video here. Okay, bye now.